Good evening, all of you. Today, I, Naveen Garg from BSc Chemistry Honors Final Year, I am going to read chapter for visually impaired students from the book of NCERT, Class 11th, Chapter 14, Environmental Chemistry. You have already studied about the environmental chemistry in your earlier classes. Environmental studies deals with all the social, economical, biological, physical, and chemical interrelations with the surroundings. In this unit, the focus will be on environmental chemistry. The environmental chemistry deals with the study of origin, transport, reaction, effects, and fatices of chemical species in the environment. Let us discuss some important aspects of environmental chemistry. Section 14.1 Environmental pollution. The environmental pollution is the effect of undesirable changes in our surrounding that have a harmful effect on plants, animals, and human beings. A substance which causes pollution is known as pollutant. Pollutant can be solid, liquid, or a gaseous substance present in a greater concentration than in a natural abundance and are produced due to the human activity or due to a natural happenings. Do you know an average human being requires nearly 12 to 15 times more times than the food? So even small amount of pollutants in the air becomes significant compared to a similar level present in a food. Pollutants can be degradable like discarded vegetables with rapidly breakdown of natural processes. On the other hand, the pollutants which are slowly degradable remains in the environment is in an uncharged form for many decades. For example, a substance such as dichloro-phenyl trichloroethane (DDT), plastic materials, heavy metals, many chemicals, nuclear waste, etc., once released into an environment are difficult to remove. These pollutants can be degradable by a natural process and are harmful to living organisms in the process of environmental pollution. Pollutants originate from a source and gets transported by air or a water or are dumped into a soil by human beings. Section 14.2 Atmospheric pollution. The atmosphere that surrounds the earth is not of a same thinking at all heights. There are concentrating layers of regions and each layer has a different density. The lowest density region of atmosphere in which the human beings along with the organic living organisms is troposphere. It is extend up to the height of 10 km from the sea level. The above the troposphere between a 10 to 50 km above a sea level lies a stratosphere. The troposphere is a turbulent, dusty zone containing air, much of water vapors and clouds. This is regions of a strong air movement of a cloud formation, and stratosphere on the other hand contains nitrogen, dioxygen, ozone and little water vapors. Atmospheric pollution is generally studied as a troposphere and stratospheric pollution. The presence of ozone in a stratosphere prevents about 99.5% of a sun harmful UV ultraviolet radiation from reaching the earth's surface and thereby protecting human and other animals from its effects. Section 14.2.1 Tropospheric pollution. A tropospheric pollution occurs due to the presence of undesirable solid or gaseous particles in the air. The following are the major gaseous and particular pollutants present in the troposphere. First is gaseous air pollutants. These are oxides of sulfur, nitrogen, carbon, hydrogen sulfide, carbon, hydrocarbons, ozones, and the other oxidants. Particulate pollutants there are dust, mist, fumes, smoke, etc. First, gaseous air pollution. From A, oxide of sulfur. Oxide of sulfurs are produced when a sulfur containing fossil fuels in burns. The most common species Sulfur dioxide is a gas that is poisonous to both animals and plants. It has been reported to that even at a low concentration of sulfur dioxide causes respiration diseases, example asthma, bronchitis, emphysema in human beings. Sulfur dioxide causes irritation to the eye, resulting a term resulting in a tears and reduced redness. High concentration of SO2 leads to a stiffness of flower buds with the eventually falls from plants. Uncatalyzed oxidation of sulfur dioxide is slow. However, the presence of particulate matter in a pollutant air catalyzes the oxidation of sulfur dioxide to a sulfur trioxide. Sulfur dioxide plus O2 changes to sulfur trioxide. The reactions can also be promoted by ozone and hydrogen peroxide. That is SO2 plus O3, it gives SO3 plus O2, and SO2 plus H2O2, it gives H2SO4 aqueous. B is oxide of nitrogen. Dinitrogen and dioxygen are main constituent of air. These gases do not react with each other at a normal temperature, but at a higher altitude when the lightning strikes, they combine to form a nitrous oxide of nitrogen. That is NO2 is the oxide of a nitrate, and NO3 negative, which is forced into a soil. When it serves as a fertilizer, it is an automobile engine at high temperature. When a fossil fuel is burned, dinitrogen and dioxygen combine to yield a significant quantity of nitric acid, nitric oxide, and nitrogen dioxide. That is N2 plus O2 at a temperature of 1483 Kelvin. It gives NO, and NO reacts instantly with the oxygen to gives NO2. The rate of production of NO2 is faster when a nitric oxide reacts with the ozone in the stratosphere. NO gas plus O3 gas is converted into NO2 gas plus O2. The irritant red haze that in the traffic and the congestion of place is due to the oxide of nitrogen. Higher concentration of NO2 damage the leaves of plants and retard the rate of photosynthesis. Nitrogen dioxide is a lungs irritating that is can be leads actual respiratory disease in children. It is a toxic to living tissue also. Nitrogen dioxide is also harmful to various textile fibers and metals. Next is C. Hydrocarbons. The hydrocarbons are composed of a hydrogen and a carbon only and are formed by an incomplete combustion of a fuel used in automobiles. Hydrocarbons are carcinogenic and they cause cancer, and they are harmful plants by causing aging, breakdown of a tissue, and shielding of leaves, flowers, and twigs. D is oxide of carbon. Carbon monoxide. Carbon monoxide CO is one of the most serious air pollutant. It is a colorless and odorless gas, highly poisonous to living organisms or human beings because of its ability to block the delivery of O2 to organs and tissue. It is produced as a result of incomplete combustion of a carbon. The carbon monoxide is mainly released into air by automobile exhausts. Other sources which are produced of CO involves incomplete combustion of coal, firewoods, petrols, etc. The number of vehicles has been increased over the year all over the world. Many vehicles are poorly maintained and several having inadequate pollutant control equipments, resulting in a release of a greater amount of carbon monoxide and other pollutant gases. Do you know why carbon monoxide is poisonous? It binds with the hemoglobin to form a carboxylated hemoglobin, which is about 300 times more stable than the oxygenated hemoglobin complex. In blood, when the concentration of carboxyhemoglobin reaches about 3 to 4%, the oxygen carrying capacity of blood is greatly reduced. This oxygen deficiency results into a headache, weak eyesight, nervousness, and a cardiovascular disorder. This is the reason why people are advised not to smoke. In pregnant women who have a habit of smoking, the increase of CO2 level in blood may introduce a premature birth, spontaneous abortion, and deformities babies. Second is carbon dioxide. Carbon dioxide CO2 is released into atmosphere by a respiration burning of fossil fuels for energy and by a decomposition of limestone during a manufacturing of cement. It is also emitted during a volcanic eruption. Carbon dioxide has been confined to a troposphere only. Normally it forms about 0 to 0.03% by volume of the atmosphere. With the increased use of fossil fuels, a large number of carbon dioxide gets released into atmosphere. Excess of CO2 in the air removed by green plants and this maintenance of appropriate level of CO2 in atmosphere. Green plants require CO2 for a photosynthesis and they in turn emit oxygen and thus maintaining of a declination of balance. As you know, deforestation and burning of fossil fuels increase the CO2 level and disturbs the balance in atmosphere. The increased amount of CO2 in the air is mainly responsible for a global warming. The global warming and greenhouse effect. About 75% of solar energy reaching the earth is absorbed by earth's surface, which is increased its temperature. The rest of the heat radiates back to the atmosphere. Some of the heat is trapped by a gas such as carbon dioxide, methane, ozone, chlorofluorocarbon compound CFCs, and water vapors in the atmosphere. Thus, they add to the heating of the atmosphere. This causes global warming. We all know that in a cold places, flowers, vegetables, and fruits are grown in a glass covered area called greenhouse. Do you know that we have humans also live in a greenhouse? Of course, we are not surrounded by glass but a blanket of air is called atmosphere, which has kept the temperature on the earth constant for centuries. But it is now undergoing a change through slowly. Just as a glass in a greenhouse sold of a sun warms inside, the atmosphere traps the sun heat near the earth's surface and keeps it warm. This is called natural greenhouse effect because it is maintains the temperature and make the earth perfect for life. In a greenhouse, the solar radiation passes through the transport gas glasses and transparent glasses and heat up the soil and the plants. The warm soil and the plant emit the infrared radiations. Since glass is opaque to our infrared radiations thermal reasons, it partially reflects the partially absorb and partially reflects and partially absorb these radiations. This mechanism keeps the energy of the sun trapped in the greenhouse. Similarly, carbon dioxide molecule also trap heat as they are transparent to sunlight but not to the heat radiation. If the amount of carbon dioxide crosses the delicate proportion of 0.03%, the natural greenhouse balance may be disturbed. Carbon dioxide is major contribution to a global warming. Besides carbon dioxide, other greenhouse gases are methanes, water vapors, nitrous oxide, CFCs, ozones. Methane is produced naturally when vegetable is burned, digested or rotted in absence of oxygen. Larger amount of methane are released in paddy fields, coal mines, from rotting garbage dumps and fossil fuels. Chlorofluorocarbon are made of industrial chemicals used in air conditioning effects. CFCs are also damaging the ozone layer. A nitrous oxide occurs naturally in the environment. In recent years, their quantities have increased significantly due to the use of chemical fertilizers and the burning of fossil fuels. If these trends continues, the average global temperature will increase to a level with many leads to a melting of polar ice caps and folding of flow-lying areas all over the earth. Increase in a global temperature increases the incidence of infectious diseases like dengue, malaria, yellow fever, and sleeping sickness, etc. Think it over. What can you do to reduce the rate of global warming? If a burning of a fossil fuel, cutting down of forest areas and add of greenhouse gases in atmosphere, we must find a way to use the just efficiently and judicially. One of the simplest things we can do to reduce global warming is to minimize the use of automobiles. Depending on the situation, one can use bicycle, public transport vehicles, or carpools. We should plant more and more trees to increase the green cover, avoid burning of dry leaves, woods, etc. It is illegal to smoke in a public places, and workplace, because it is harmful not only for you who is smoking, but also for other who are there with. Therefore, we should avoid it. Many people do not understand the greenhouse effect and the global warming. We can help them by sharing the information that we have. Next is acid rain. We have aware about the naturally rainwater has a pH of 5 to 6 due to the presence of H positive ion formed by a reaction of rainwater with carbon. With the carbon dioxide present in the atmosphere, that is H2O plus CO2, it gives H2CO3, and H2CO3 is in equilibrium with the H positive and HCO3 negative ion. When the pH of a acid rainwater droplet below 5.6, it can be called as acid rain. The acid rain refers to the way in which the acid forms the atmosphere is deposited on the earth's surface. Oxide of a nitrogen and a sulfur, which are acidic in nature, can be blown by a wind along a solid particle in the atmosphere and finally settle down the other depositing or in a water fog and now snow as a water deposition. Acid rain is a byproduct of variety of human activities that emits the oxide of sulfur and nitrogen in atmosphere. As mentioned above earlier, that burning of fossil fuel which contains sulfur and nitrogenous matter such as coal and oil in power stations and furans or petroleums and diesels in motor industries produces sulfur dioxide and nitrogen the oxides SO2 and NO2 after oxidation and reduction with the water, the major contribution to the acid rain. Because the polluted air usually contains particulate matter that is catalyzed the oxidation, that is twice of SO2 plus O2 plus H2O, it gives H2SO4, and twice of NO2 plus O2 plus H2O, it gives HNO3. The ammonia salts are also formed and then can be seen with the atmospheric haze aerosol of fine particles. Aerosol particles of oxides of ammonium salts in acid droplets results in a wet deposition. SO2 is also absorbed directly with both the solid and the liquid ground surface, and it is such a deposition of a dry deposition. The acid rain is harmful for agriculture, trees, plants, and it is a dissolve in a washing. They have nutrients needed for their growth. It causes respiratory alignments in human body and animals. When the acid rain falls on the floor as groundwater to reach rivers, lakes, it affects the plant and animals in aquatic ecosystem. It corrodes the water pipes, resulting in a leaching of a heavy metal such as iron, lead, copper into a drinking water. The acid rain damages buildings of other structures made of stones of metal. The Taj Mahal in India has been affected by the acid rain. The particulate pollutants. The particulate pollutants are a minute solid particles or liquid droplets in air. They are present in vehicles emission, smoke particles from fires, dust particles, and ash from industry. A particulates in atmosphere may be of a variable and non-variable. The variable particulates, example bacteria, fungi, moduli, algae, etc., are minute living organisms that have a dispersed in atmosphere. Human beings are allergic to some of a fungi found in air. They are a cause of plant diseases. The non-viable particulates many classified according to their nature and size of flow. First is smoke particulates consist of a solid or a mixture of a solid or liquid particles formed during a combustion of organic matter. Example: cigarette smoke, smoke from burning fossil fuels, garbage and drying living leaves, oil smoke, etc. Second is dust is composed of fine holes, solid particles over of 1 micrometer in a diameter, produced during a crushing grinding attributes to a solid material, sand from a sand blasting, sawdust from a woodworks, pulverized coal, cement, and fly ash of factories. Dust, smoke, etc. are some typical examples of a particulate emission. Mist are produced by the particles of spray liquid and by the condensation of vapors in airs. Examples are sulfuric acid mist, and herbicides and insecticides and miss their targets and travels through air from a mist. D. Fumes are generally obtained by the condensation of vapor during a sublimation, distillation, boiling, and several other chemical reactions, generally organic solvents, metals, and metallic oxides to form a fume particle. The extent of particulate pollutants are largely depends on the particle size. Airborne particles such as dust, fumes, mist, etc. are dangerous for human health. The particulate pollutants bigger than 5 microns are likely to be loads of a nasal passage, whereas particles about 10 microns are enters into a lungs easily. Lead used to be a major air pollutant emitted by a vehicle. Leaded petrol used to be a primary source of airborne and lead emission in Indian cities. This problem has now been overcome by using a unleaded petrol in most of these Indian cities, and leads to interfaces the development of a manufacturing of a red blood cells. Next is smog. The word smoke derived from a smoke and fog. There is a most common example of air pollution that comes with many cities throughout the world. There are two types of smoke. First is classical smoke, occurs in a cool, humid climate, and it is a mixture of smoke, fog, and sulfur dioxide. Chemically, it is a reducing mixture of, so that it is called a reducing smoke. Second is photochemical smoke, occurs in a warm, dry, and sunny climate. The main component of photochemical smoke results for the action of sunlight or on unsaturated hydrocarbons and nitrogen oxide produced by automobiles and factories. Photochemical smokes have a high concentration of oxide agents, and therefore they're called as oxidizing smokes. Formation of a photochemical smoke. When a fossil fuels are burned, a variety of pollutants are emitted to the Earth's troposphere. The two pollutants that emitted are the hydrocarbons, unburned fuels, and nitric oxide (NO). When these pollutants builds up a sufficiently highly level, a chain reaction occurs from a interaction with the sunlight, in which NO is covered with the nitrogenous oxide NO2. This NO2 is turns absorbs energy from sunlight and breaks up with the nitric acid and free oxygen NO2. NO2, in presence of light, it gives NO plus O2. The oxygen atoms are very reactive and combines with the O2 in the air produce ozone. The ozone formed in the above reaction reacts rapidly with the NO gas formed in a rapid reaction and regenerates NO2. NO2 is a brown gas and has a sufficient high level, or can be attributed to the H. The NO gas plus O3, it gives NO3 plus O2. The ozone is a toxic gas, and both NO2 and O3 are stronger oxidizing agent, can be reacts with the unburned hydrocarbons in a pollutant air to produce a chemical such as formaldehyde, acrolein, and peroxoacetylene nitrate (PEN). Effect of photochemical smoke. The common component of photochemical smokes are ozone, nitric oxide, acrolein, formaldehyde, and polyoxyacetyl nitrate (PEN). The photochemical smoke cause serious health problems. Both ozone and PEN acts as a powerful eye irritants. Ozone and nitric acid irritant the nose and throat for their higher concentration, cause headache, chest pain, dryness of throat, cough, difficulty in breathness. Photochemical smoke leads to a cracking of a rubber and existentially damaging the plant life. It is also cause corrosion of metals, stones, building materials, rubbers, painted surfaces, etc. How can photochemical smoke be controlled? Many techniques are used to control the reduction of a formation of a photochemical smoke. If we control the primary pressures of a photochemical smoke such as NO2 and hydrocarbons or secondary pressures such as ozone and a pen, the photochemical smoke will automatically be reduced. Usually catalytic converters are used in automobiles which are prevented the release of nitrogen oxide and hydrocarbon to the atmosphere. The certain plants, pioneers, examples are there in plantations could be helped in this matter. Section 14.2.2 Stratospheric pollution. Formation of a breakdown of ozone. The upper stratosphere consists of a considerable amount of ozone O3 which protects us from a harmful ultraviolet UV radiation of wavelength 255 nanometer coming from a sun. These radiations cause skin cancer, melanoma, and melanoma in humans. Therefore, it is important to maintain the ozone shield. The ozone is the stratospheric it produces of UV rays acting on a dioxygen molecule. The UV splits apart one molecule into a free oxygen. These oxygens combines with the molecular oxygen to form ozone. O2 in presence of UV light it gives O plus O, and O plus O2 it gives O3. The ozone is thermodynamically unstable and decomposable to a molecular oxygen. Thus, a dynamic equilibrium exists between the production and decomposition of ozone molecule. In recent years, there have been reports that depletion of protective ozone layer because of a presence of a certain chemicals in a stratosphere. The main reason of ozone depletion is believed by the releasing of CFCs, chlorofluorocarbon compound, also known as freons. These compounds are non-reactive, inflammable, non-toxic organic molecules and therefore used in refrigerators, air conditioners, in the production of a plant formed by an electronic industry for a cleaning of computer parts. Once CFCs are released in atmosphere, they mix with the normal atmospheric gases and eventually reaches the stratosphere. In stratosphere, they will be broken down by a powerful UV radiation releasing of a chlorine free radical CF2Cl2 UV changes to Cl free radical and changes to CF2Cl free radical. The chlorine radical reacts then with the stratospheric oxygen and to form a chlorine monoxide. The chlorine radicals are continuously regenerated and cause a breakdown of ozone. Thus, CFCs are transporting agents for continuously generating chlorine radicals into a stratosphere and damaging of ozone layer. The ozone hole. In 1980, the atmospheric scientists working in Antarctica reports about the depletion of ozone layer commonly used known as ozone hole over a South Pole. It was found that a unique setup of a continuous was responsible for an ozone hole. In summer season, the nitrogen dioxide and methane reacts with the chlorine monoxide reaction, chlorine atom, and forming a chlorine sinks, the preventing of much ozone depletion. Where in a winter, a special type of clouds called polar stratospheric clouds are formed by over Antarctica. These polar stratospheric clouds provides a surface on a chlorine nitrate form. Reaction 4 gets hydrolyzed and 2 gives a hypochlorous and acid in it is also reacts to with the hydrogen chloride produced as per reaction and to give a mono. When sunlight returns to Antarctica in spring, the sun warms break the cloud of HOCl and Cl2 as a photocatalyzed by sunlight as given in a reaction. HOCl it gives HO free radical and Cl free radical in presence of light, and Cl2 gas gives 2 Cl free radical. The chlorine radicals thus formed initiate the chain reaction of ozone depletion as described earlier. Effect of depletion of ozone layer. Effect of depletion of ozone layer. More UV radiation filters into a troposphere. UV radiation leads to a aging of a skin, contract, sunburning, skin cancer, killing of a many pyrocharates, damaging of fish productivity, etc. It has also been reported that that plants affected by the UV radiation, which leads to the harmful mutation of cell. It is also increase in evaporation of a surface water through a stomata of a leaves, and diseases decreases the moisture content of soil, increasing in UV radiation, damaging the paints and fibers, causing them of a fading faster. Section 14.3, Water pollution. Water pollution is essential for life. Without water there would be a no life. We are usually water as a grant for its purity, but we have to ensure that a quality of water. The pollution of water originated from a human activity through a different paths. Pollutants reach surface on a groundwater easily. Indefinite of a source of place of pollution is called point source. Example: municipal and industrial discharge pipes. Whereas pollutants enter through a water source, and not point sources of pollution are those of where source of pollution can't be easily identified. Example: agricultural runoff from farm animals and croplands, acid rains, storm water, drainage from street, parkings, lawns, etc. are the sources of water pollution. Section 14.3.1, Cause of water pollution. First is pathogen. The most of the serious water pollutants are diseases causing are called pathogens. Pathogens include bacteria and their organisms that enters the water from a domestic sewage and animal extract. The human excreta contains a bacteria such as causes gastrointestinal diseases. Organic waste is other major water pollutant is organic matter such as leaves, grass, traces. The pollute water as a consequences of runoff. Excessive pyroplankton growth within water is also a cause of water pollution. There is a wastage of biodegradable. The larger pollution, the large population of bacteria decomposes organic matter present in water and cause of a dioxin dissolve in water. The amount of oxygen that of water are hold in a solution is limited. In cold water, dissolve of oxygen can reach to a concentration up to 10 ppm parts per million, whereas the oxygen is in air is about 20 lakh ppm. That is why even in the moderate amount of organic matters when decomposes in the water and that depletes the water, it dissolves oxygen. The concentration of dissolved oxygen in water is very important for aquatic life. If the concentration dissolved in oxygen in water level below 6 ppm, then the growth of fishes gets inhibited. Then oxygen reaches water either through atmosphere or from a process of photosynthesis carried out by a many aquatic green plants during daylife. However, during night photosynthesis stops, but the plants continues to respire, resulting in reduction of a dissolving of O2. The dissolving of O2 is by microorganisms to oxide organic matters. It is too much of organic matters is added of a water. All these available oxygen is of made up of this is cause of oxygen dependency aquatic life to die. Thus anaerobic bacteria which do not require oxygen beings of breakdown of organic waste and produce chemicals that have a foul smell and harmful to the human health. Aerobic bacteria degrades these waste for organic waste and keep the water depleted in a dissolving oxygen. Thus the amount of oxygen required by bacteria break down the organic matter present in a certain volume of a sample water. It is a biochemical oxygen demand. The amount of BOD in the water is the measure of amount of organic material in the water and in terms of how much oxygen will be required to break its biodegradably. The clean water would be have a BOD, that is biochemical oxygen demand value of less than 5 ppm, whereas highly polluted water cloud be of B have a BOD value is of 17 ppm or more. Third is chemical pollutants. As we all know that the water is an excellent solvent, water soluble in inorganic chemicals that includes a heavy metals such as cadmium, mercury, nickel, etc. constitute an important class of pollutants. All these have a metal and dangerous of humans because of our body can't be excrete them. Over the time it crosses the tolerance limit, then these metals have may cause a kidney, central nervous system, livers, etc. The acid like sulfuric acid, and for a means of drainage there are many different sources including raw materials, salts such using melt, snow, ice in colder climates. Sodium and calcium chloride are water soluble chemical pollutants. The organic chemicals are the another substance of that of found in a pollutant water. The petroleum produced the pollutant may be of sources of water. The organic chemicals are the another group of a substance that forms in a pollutant water. Petroleum products pollute many sources of major soil splits in the oceans. Other organic substances that have serious impact are the pesticides and the drift drown of sprayers run off from lands. Various industrial chemicals like photochlorinated biphenyls (PCBs), which are used as a cleansing solvent, detergents, and fertilizers, adds to a list of water pollutants. PCBs are suspected to be a carcinogenic. Nowadays, most of these detergents available are biodegradable. However, their use can be of other problems. The bacterial responsible for a degradation of biodegradable detergents used feed on it and growth rapidly. While growing, they may be have use of up all the oxygens dissolved in water. The lack of oxygen kills all these other forms of aquatic life such as falls, fishes and plants. Fertilizers contains phosphates and other additives. The addition of phosphates in water enhance the algae growth. Such focus of growth of algae converts the water surface and the reduce of dioxygen concentration in water. This leads to anaerobic condition, commonly with the accumulation of anaerobic decay and animal death. Thus, blooms in fast water inhibit the growth of living organisms in the water bodies. The process is of nutrition of enrich of water body supported in a dense plant population which kills the animal's life by depriving it is oxygen and results the subsequent loss of biodiversity known as eutrophication. Section 14.3.2, that is the international standards for drinking water. The international standards for drinking water are given below, that is of fluoride. For a drinking purpose, the water should be a listed of fluoride ion concentration. Its deficiency in drinking water is harmful to men and cause of diseases of tooth decay, etc. Soluble fluorides is often added to drinking water to bring a concentration up to 1 ppm or a 1 milligram of per decimeter cube. The F negative ions makes the enamel to the teeth much harder and converting hydroapatite, that is 3 times of Ca3PO4 whole twice CaOH whole twice the enamel on the surface of teeth into a much harder fluoroapatite, that is Ca3PO2 dot CaF2. However, the ion concentration above 2 ppm cause brown mottling of a teeth. At the same time, excess of fluorides over a cause of a harmful effect on the bones and teeth reported to some parts of Rajasthan. Lead. Drinking water gets contaminated when lead when the lead pipes are used for transportation of water. Sulfates. Extensively sulfate greater than 500 ppm in drinking water cause a laxative effect, otherwise that of a moderate level in a harmless. Nitrates. The maximum limit of nitrates is of drinking water is 50 ppm. Excess of nitration in drinking water can be of cause of disease such as myoglobin, blue baby syndrome. Other metals. Maximum concentration of some common metals recommended in a drinking water.